Good morning, everybody. My name is Sandra Urrutia. And I'm going to be discussing using alignrt, inbore sgrt technology with inbore-based linear accelerators. A little bit about myself. I have a little over 10 years of experience as a radiation therapist. The majority of my career has been at UCSD, where we've always used some sort of surface-guided radiation therapy. So the addition to the board-based sgrt is something fairly new to us. So a quick overview of our department, UCSD Department of Radiation Oncology. We have a total of 4 linear accelerators, a CT scanner, and an HDR suite. Our linear accelerators consist of 2 true beams, and our board-based linear accelerators, we have 1 ethos and 1 halcyon. Our department census is currently at 200 patients with 4 machines, so the majority of our patients go to our board-based linear accelerators. They have the higher patient census. And because we're talking about board-based linear accelerators and sgrt, we're going to focus here on our ethos and our halcyon. We acquired our halcyon in 2017 and our ethos in 2021, along with our inbore alignrt for both in 2021. We do treat a variety of different patients on our ethos and our halcyon, but I'm going to be focusing on our breast treatments, brain treatments, and our extremity treatments, which I'll go over here shortly. Okay. So what is inbore sgrt and how is it helpful? It allows us for real-time active monitoring our patients during this process of the setup and the process of treatment. The real-time active monitoring system definitely helps us in our day-to-day setups and our day-to-day treatments for our patients. It also helps limit the amount of x-rays needed for a difficult setup and does not emit any additional radiation. So, ALARA for my radiation therapists. It works as a verification system. It's a second pair of eyes for us. In a busy clinic, it's easy to get distracted, so having this tool is somewhat of a comfort to us in our daily workflows and our daily treatment setups and delivering of treatment. Because we are a busy clinic, efficiency is key. So having this tool in our tool belt adds efficiency to the workflow in our department and minimizes the amount of time that the patient is on the table. And to quote a speaker from yesterday, a happy patient is what? A happy therapist? Is that right? Did I hear that right? So we like to keep our patients happy, and everybody else likes to keep the therapist happy. So I just want to take a minute here to compare and contrast what we're used to and what we're not so used to. Again, we have 2 true beams in our department, and we have certain tools that are different when you're comparing the true beam and the board-based linear accelerators. So for the true beams, we're used to having an ODI. We're used to having a physical light field so that we can check flash. And if you're lucky, you have a 6 degrees of freedom couch, which is extremely helpful. And our lasers are at isocenter. So there are clinical tools that we use to help us feel confident in our daily setups. With a board-based linear accelerator, it's a little different. We don't have an ODI. We're unable to verify the physical light field, so we can't check the flash. We have 3 degrees of freedom, so we're doing a lot of manual movement. And then we have 2 setups. We have a setup at we have a setup ISO center, and we have a treatment ISO center. So we're setting up essentially at setup ISO, and then we push the patient into treatment ISO. So in a way, I know when I was being trained on our bore-based linear accelerators, I felt somewhat uneasy with our bore-based setups because I was so used to the clinical aspects of our setups on a traditional linear accelerator. I point this out because having a surface-guided, the surface-guided technology, again, adds a level of reassurance to myself and my team at home. Okay, so I'm going to break down the components of our inbore alignrt. The first photo here is a photo of our ethos. I'm sorry it's so small. But right inside of the bore, you can see the inbore ring. It's attached to the inside of the bore and actively monitors patient movement while the treatment is being delivered. Our ceiling-mounted cameras are our pods. They assist with the setup mode of the workflow, and that's the red light, or the surface-guided red light that we use prior to treatment. And then we have our alignrt computer software. This software allows us to do the daily quality assurance for our alignrt, and it allows us to select and adjust the ROI as needed per patient. And then it helps us with the patient setup, giving us our tolerances and allows us to monitor patient intrafractional movement. So again, the most common treatment sites that we see at UCSD and that we use alignrt with are our breast tangents, which includes deep inspiration breath hold, or DIBH, and free breathing. We also treat our brain patients, partial and whole, and then our extremities, our arms, shoulders, and legs. So this is a photo of a common setup for our breast treatment. We have our wing board with the soft A headrest and our knee fix. And as I'm sure most of you know, the bars can be adjusted depending on patient need, and we may also add a pad depending on what the patient needs. So I'm going to walk through our workflow, and then we'll see a video. So once the patient is on the table, we're going to select the free breathing scan on alignrt for the patient. Under the setup mode, you're going to press the play button. The ceiling-mounted cameras will turn on. We're going to bring our patient up to setup ISO or pseudo ISO. We adjust the vertical, the lateral, and the longitudinal using the machine controls. And we're going to adjust the yaw, the pitch, and the roll by manually moving the patient. Once the patient is in position and is within tolerance, you're going to pause the video feed, select the DIBH scan, and press play. You're going to instruct the patient to take a breath in and hold, and you'll see that the patient will move into tolerance for treatment. Once everything looks good, you're going to switch to treatment mode and load the patient for treatment. Okay, so here's my video. We've selected the free breathing scan. We're adjusting the long, the lat, and the vert to get into tolerance, and we're adjusting the patient for the yaw, the roll, and the pitch. And again, this is all under the free breathing scan. Once the patient is within tolerance, we pause the video, we select the DIBH scan, and of course, it's gonna be different, but we're gonna instruct the patient to take a breath in and hold. And as you can see here, she falls nicely within the tolerance. We switch over to treatment mode, load the patient in for treatment. And keep in mind, our breast treatments are tattoo-less. It is a tattoo-less workflow. I want to go over the image here. This is our image match. It's probably too small to see what our shifts ended up being for that session, but our vertical shift was a 0.04 centimeters. Our longitudinal shift was 0.17 centimeters, and our lateral shift was 0.1 centimeters. So these are extremely small shifts, which equals inaccurate treatment for our patients. Our average treatment time from the start of the CBCT to the beam off is 3.2 minutes. It is a fairly quick process, with our CBCT taking about 17 seconds. So if our patients are good candidates for DIBH, they can get through this treatment with no problem. The only difference between the DIBH workflow and the free breathing workflow is that at the drop-down menu, obviously there will not be any DIBH scan to continue on. You would just stick with the free breathing scan. Okay, so this is our brain treatment workflow. This photo here is the setup for our brain treatments. We have an S-frame on the table. It's a little difficult to see with the pad. We use a Q3 headrest with a custom cushion, short mask, and a knee fix. And again, under the setup mode, we're gonna press the play button. The ceiling mounted cameras will turn on. We'll bring the patient to set up ISO. We again adjust the vertical, lateral, and longitudinal using the machine controls. And we adjust the yaw, the roll, and the pitch manually by moving the patient. Once the patient is within tolerance, we switch to treatment mode and load the patient for treatment. I'm going to share with you another video of our workflow. So we have our vert, our long, and our lat, and our yaw, our roll, and our pitch. Again, we're adjusting the vert, the long, and the lat using our controls, and we're manually adjusting for the yaw, the roll, and the pitch. And again, this is all at our setup ISO under the setup tab, right down there. So once the patient is within tolerance, we're gonna pause the video, switch to treatment mode, and press play. So on average, the magnitude of our shifts were anywhere from 3 to 4 millimeters in the vertical, the lateral, and the longitudinal direction. And out of 21 patients that are currently using SGRT for this treatment, only 1 patient had to be rescanned. Ultimately, it was a difficult setup. The mask didn't fit well, and we assumed that the patient had moved during SIM. So the patient was returned to SIM for a resim. Okay, so it's not always rainbows and butterflies. the last two examples that I showed you are fairly easy to follow examples. Our extremity treatments tend to be a little bit more difficult for a number of reasons. One, because they're extremities, right? And two, because in this case, this patient is what we call a dual ISO, which means that it is a fairly large field that we're treating that cannot fit within one treatment, one ISO, so it's dual ISO. We're breaking it up into two ISOs essentially. And you'll see here in the video in a moment, it takes a little bit longer for the therapist to get the patient in position. And right now it's a little glitchy because we're so far from setup ISO. It's difficult for the cameras to read. But once we get a little bit closer, we can fine tune the patient's position. Again, using the vert, the long, and the lat, adjusting those by using the controls on the machine, and adjusting the yaw, the roll, and the pitch by manually moving the patient's leg. It also can get a little glitchy because you can see here, oops, sorry. Oh, I don't know if it's gonna play again. There it goes. In part of the video, it gets a little glitchy because you can see the therapist's arm or hands adjusting the patient. So the feed can be a little glitchy and can cut in and out slightly. But all the hard work to adjust this patient pays off in the image match. So for this session, our image match resulted in the following shifts. Our vertical shift was a 0.02. Our lateral shift was a 0.06. Sorry, 0.7 on the lunge. And our lateral shift was a 1.3. So the largest of those three values was the lunge. All in all, it's a fairly small shift, and it shows in the effort and the time that the therapist put in to set up this patient here. Okay, moving on to my quality assurance slide. So at the computer monitor, we're going to be selecting the daily QA, which all in all takes maybe 3 minutes in the morning. In general, quality assurance for an ethos or a halcyon is extremely quick compared to our traditional linear accelerators. We allow a 30-minute time slot in the morning to do the quality assurance on the machine, and that also includes the quality assurance of our alignrt system. So once we've selected the daily QA, we head over to the table and we put our polka dot board down and we set it up to set up ISO. Once we're at setup ISO, we capture the images using the external camera pods. We drive the couch into treatment ISO and take another set of images, and the system will check for the calibration of the two systems, so the camera pods and the inbore system, to verify that they are accurate. So the future of inbore sgrt, again, we've had our ethos since 2021, and we've had the inbore also attached since 2021. The majority of our patients are just regular treatments, but we do have around 3 to 4 adaptive plans per day on our ethos. So our physicist, Dr. Kissling, has added to the workflow the use of our inbore alignrt system. We don't necessarily use it for setup per se, because these patients do have tattoos and the workflow still consists of setting up to those tattoos, but we do actively monitor the patient once the patient is set up for treatment. I don't know if anybody here is familiar with adaptive plans, but they take a fairly good chunk of time, anywhere from 20 to 40 minutes. We do schedule our adaptive plans out in an hour time slot. So you'll see here the workflow is slightly different. We're going to go straight into treatment mode, press play, take a reference capture, and start monitoring the patient. And of course, the patient, depending on their breathing pattern, they'll fall in and out of tolerance. But you have a baseline to follow. And that goes back to the second pair of eyes. Our adaptive workflow is a little different. We have obviously our physicists there and our doctors to approve the new plan. But our role as a therapist is to be their second pair of eyes. So we're able to do that by using the inbore alignrt system. Okay, that concludes my presentation. I just wanted to give a quick thank you to my team back home. And also, UCSD is hiring, if anybody's interested.